Good morning, geometry. Today's video is the last section of chapter 13. We'll be looking at section 13-4. We're going to be looking at some problems in solving using trigonometry. And our essential question for today is, how can you solve a right triangle? And after perusing the section, we're going to be looking at finding area of triangles using trigonometry. Look at finding the lengths of sides of a triangle and the measure of the triangle's angles. All right, let's go at it. So, how can you solve a right triangle? So this section, okay, well, let's just go back. Let's keep going, Vince. How can you solve a right triangle? So down below here, and going into our notes, take the time and pause the video, write down this information, and then we'll come back and talk it through. All right, you're back. If you look at the very first part of the Explorer, it says you can use trigonometry to find the area of a triangle without knowing its height. Now, this section, or this part of this section, is they did not say what type of triangle this is. We already know that you can find the area of a right triangle by taking the product of 1/2 times the base times the height of the triangle. So if we want to find any other type of a triangle, specifically an obtuse triangle, we got to know its height. And in geometry, when we talk about height, we're looking at the altitude. So here we have two pictures. Here is a triangle ABC. Corresponding sides are opposite of their angles. And what they did here in this other picture is they drew an altitude. So from this picture right here, we can find the area of a triangle. In this case, this is an obtuse. And we can find the area of the triangle. So going back, using this problem, this part right here, they focused on angle C, okay, to be able to find the area. So to find the angle C, we have to use the SO. The sine is opposite divided by the hypotenuse. So using this right triangle right here, we can find out what our height is, because we need the height to be able to find the area of an obtuse triangle. So again, the sine of this angle, once again, is the opposite side, which is AD, divided by the hypotenuse. In this case, it's the length of AC. Again, putting it in terms of using the sides here, okay, we know that the sine of C will be the altitude, or the height, divided by B, or the hypotenuse. So we can say that the sine of C is h over b. Now we need that for the next part. So the next part is you take that sine of C equals h over b, and you solve for h. So we just multiply both sides by a b. And then the next part is complete this formula in terms of h. All right, what it means is we want to go ahead now and use h, or actually the b sine c, within the area of a triangle. So we already know the formula area of a right triangle is 1/2 times the base times the height. Well, again, if we apply what we just said, okay, we know area is going to be 1/2 of the length, or in this case is A. That's this side right here. Or actually, let's back it up. That's this side right here. That's where this A is. It's this side right here, times its height, or its altitude. And we already found that this is the altitude. We did that over here. So what you can do now is, we already know that h is sine C. So we take the b sine C and substitute it into the h, and we get this guy right here. 1/2 times A times b sine C, and that will give you an area of an obtuse triangle, or in this case, an area of a triangle that is not a right triangle. All right? Next page. The next page goes into the top of the page. Suppose you used a trigonometric ratios in terms of angle B, height h, and a different side length. How would you change your findings? And what did this tell you about the choice of sides, including angle? Well, using sine of B, we know sine is opposite divided by the hypotenuse. So now the opposite side is AD divided by the hypotenuse, which in this case is AB. And we know that now the sine of B equals the altitude divided by the hypotenuse of this triangle. So we derived another formula. Now this one is based upon angle B. The one we did earlier, we did it based upon angle C. So with that said and done, we have now, and you can put in your H, G, and C's, the area formula for a triangle in terms of its side lengths. Now that means it depends, what the formula you use depends on what side lengths are given. So again, we can use this formula, and then this is dependent upon knowing the length of side B, side C. We can use this formula if we're given the length of side A and the length of side C. And we can find this area if we're given the length of A and the length of B. All right, now down below in the example 1, they did an example for us. You guys have that in your book, so let's go to page 724. Or excuse me, 725. So at the top of the page, without going too further, we have triangle DEF. So I just made a triangle DEF. Again, we know DE is 9 inches, and we know DF is 13 inches, and we know the measure of angle D is 57. So based upon this, we're working with this angle right here. Okay. Again, they're taking this part right here, just giving you an idea. They're just taking all this part, this stuff, and separating it, doing it like what they did in the previous sections. Okay. I'll let you guys study that. All right, now the your turn is 2 problems. So question number 3, find the area of each triangle to the nearest tenth. All right, so if I start with this one, we stop and look at the problem. What I did is I just labeled this triangle ABC. Okay, I could have gone ABC, I could have gone ABC. It does not matter in this example, or when we're dealing with triangles. It's just how you label your diagram. So if we look at here, we have angle A, which is 34. We have side C, and we have side B. That's all based upon labeling this triangle. So I go to the 3 formulas over here, and you got to stop and ask yourself, I am giving an angle A, given angle side B, and the measurement of side C, and you got to ask yourself which one of these 3 are you going to use. Well, based upon the problem, it looks like we're using this one right here. Now the reason I'm saying this is because you got to go by how you label your triangle, how you label your sides, and where you in assigning this as your first angle. You guys can do that. So plug it in. Again, using your calculator, all we do is go 1/2 times length of B, which is 15 millimeters, times length C, which is 12 meters, times the sine, press the sine button, of 34 degrees, and hit enter. And you'll get 50.327, and the directions say to the nearest tenth. So it would be 50.3 millimeters squared. That's the area of that triangle. All right, here's what I'd like you to do now. I would like you to stop the video. I want you to take your turn number 4, and work it out. Unpause your video and see what you did. All right, you're back. All right, we got triangle PQR. Side length of PQ is 3 centimeters. Side length of QR is 6 centimeters. And the measure of angle Q is 108 degrees. Now, once again, they gave you the triangle already labeled. You with me? And again, just for purposes, they gave us angle Q. They gave us side length PQ. And they gave us the side length of QR. And if you look at what you're given capital letter C, lowercase b, and lowercase a. Now, the reason I brought that up is because and since we're so used to what we did earlier, I just substituted the P with the A, the R with the B, and the Q with the C. You could do that. Okay, I just kept it this way so you can tie into these formulas. Okay, you don't have to. You just got to go back and replace things. What you could have done here is, we know we're going to be using this formula. Okay, because we know we have angle C, we have side A and side B. What you could have done here is you could have let that become A, actually lowercase p. Again, this could have been lowercase r and then the sign of Q. It doesn't matter. I just wrote it down in A, B, C so you guys can see it. So you do your math. There you got it. There you go. All right. Again, this is the area. Not letting you see it. These are finding the area of your area of a triangle. And it all depends on what they give you and how you labeled your triangle. Like we used this one right here. We could have used this second one here by first making sure that this is B. We could have said A, B, C. It doesn't matter. It's how you label it and what do you assign to your this side, and that angle. You can handle it. All right, next page is solving a right triangle. And what they're using here is the Pythagorean theorem. Again, the Pythagorean theorem is nothing more than the length of the square of the length of one side plus the square of the length of another side. Its sum must equal the square of the hypotenuse side. Nothing new. I'll let you guys peruse that. Down below, letter B. Pause your video, write that information down, and see how they got it. Again, I think one part right here is when you get to this part right here, they're going to ask yourself, how did you get this? Well, we're trying to find out what the measure of angle A is. So we have to get rid of the cosine. So we have to divide both sides by the cosine. So that's where we get the inverse cosine. Now again, to find your calculation, you do second inverse. So you get the cosine inverse of 7 divided by 9. Enter. And you'll see that it's going to become 38.9 and round it to the nearest whole number. That'll be fine. Are you with me? All right, page 727. They did, I'll let you guys do this on your own. We have a building, cast a 33-meter shadow when the sun is at an angle of 27 degrees to the vertical. So in other words, the sun's up here. How tall is the building to the nearest meter? How far is it from the top of the building to the tip of the shadow? And what angle does a ray from the sun along the edge of the shadow make it to the ground? So we have to, in this case, you have to use several different things. So I'll let you guys study that, okay? And it's all based upon your three trig functions: sine, cosine, tangent. And in some cases, you may have to use the Pythagorean theorem. And also, you'll probably need to have to go and use the complementary rule. That means the sum of two angles have got to equal 90 degrees. All right. Now, the next one takes a little bit longer to do, is solving a right triangle when we're dealing with the coordinate plane. So I think we'll go and do one example of that, and that should help you out in that section. So here we go. Let you guys take a moment, pause your video, save it, and then come on back. All right, you're back. Here we have triangle DEF has the following vertices: -4, 3, 3, 4, and 0, 0. So I took the time and graphed -4, 3, 3, 4, and 0, 0, and labeled them as such, DEF. We want to find the lengths of the sides. We want to find this length, and this length to the nearest hundredth, and the angle measures to the nearest degree. So we have 6 things to do here. Find the length of this side, the length of this side, the length of this side, and the 3 angles. So we got quite a few things that are going to be involved in this. Some things you probably forgot about. So the first thing we need to do is we need to find the slope of each side. That's what they're showing us. Again, here is the slope formula. Again, also remember your book will have this. Remember, that's a 1. It doesn't matter which one of these two you want to use. You're still going to get the same slope. All right, now this next part is going to tell us right off the bat that angle F is 90 degrees. Now, I know some of you probably got stuck right there. You're probably saying, why? Well, one of the rules that we dealt with a while back, you probably forgot about it, is that anytime you have the product of two slopes and their product is -1, that means it's going to be a perpendicular line. So in other words, when the reason we did these two is we see that this has a positive slope of 4/3. This one has a negative slope of -3/4. And if you take those two slopes, multiply them, and if you get a -1, that means these two sides are perpendicular. And I can use a different color now. We know now that this is a right angle. So that tells us the measure of angle F is 90 degrees. All right, the next thing we got to do is to be able to find out what these angles are. We have to go and do a little bit of math. So we have to find the distances of these 3 sides using the distance formula. All right, you should be able to handle that. All right, now we notice right off the bat that DF and EF have the same length. So that right there should tell you a little bit about this problem. This one is an equilateral triangle. No, I probably messed that up. It's been a while, but these two sides are the same length. So again, we can find the measure of angle D. So the measure of angle D, once again, you can use, in this case, they're using sine. So that means sine is so it's opposite over the hypotenuse. So they use the opposite side, which is length of EF, divided by the hypotenuse, which is the measure of DE. We already found those. Plug it in. Find the inverse sine of that. We get 45 degrees. And that means this other side has to be 45 degrees, all because of complementary. So that is what section 13-3 is all about. I think you guys can do the rest. I think you guys can. So how can you solve a right triangle? Got to take the time and make the triangle. Ask yourself how you're going to do it, what formulas you're going to use, how you're going to think it through. All right, guys. Catch you later. Bye.